Hello, welcome to Technoveda Solutions. This video, we are going to discuss about the programming model. So in the previous session, we discussed about the compilation process. Here we are going to discuss how exactly the programming is organized or program is organized. So we start with the header files. So there are two types of header files. One is standard header file, which is included using the angle brackets, and another one is user-defined header file, which is included using a double quotes. So these are the two different types of header files we can have in a programming. So both are using a keyword hash include, and we know that any instruction starting with a hash symbol is a preprocessor. So header file inclusion is also comes under preprocessing. Let's see other preprocessors. So other preprocessors are macros, conditional compilation, and other directives we have. So we'll be seeing them one by one. Before that, let's discuss about the global and external declarations. Whenever we want to have a particular variable to be used in only one function, then we declare a variable as a local variables. However, whenever we want a particular variable to be used in more than one function, or multiple functions want to use a particular variable, then we declare such variables as a global variables, and we can use those global variables with any functions. So it will be available for the entire program. Then we have another type of variable which are external declarations. Here what happens, we are declaring a variable in one file and we are using it in the other programming file. So such declarations are used whenever we want to share the variables between two different programs. Then we can declare a variable in the third file as an external, and then we can use that in our source code. So when we are using external variables in the source code where we are using it, there the memory is not allocated, only it is defined there. The declared memory will be allocated only for the external variable which is declared in the third file. That's how the external variables are used. Now coming back to preprocessors. So we have something called the macro expansion. So macros can be used in many different ways, and what is the advantage and what are the limitations of the macros, that will discuss again in detail when we are comparing that with the functions. Right now we'll see just an example how do we use them. We use with the keyword hash define. Again, this preprocessor, we know that starting with the hash symbol. Then we'll have one token and a value given to that token. So here you can see the first example where the token is given is pi. The name is given to a particular numerical value, so that we can avoid any lexical errors which can happen during the program. Then we can also use this macro to give a logical explanation for a particular symbols. So we can see there are a couple of ampersand symbols which perform AND operation. So to give a meaningful name, we are using a macro and we are defining the token as AND. Similarly, we can have a small equations being evaluated in the macros itself. So we can see that there is an area which is passed, a value x is passed to that, and that value is used to evaluate the expression. So we can just use that macro wherever we want to calculate the area. Okay. Then we have a conditional compilation. Now already we know generally conditional, whenever we want to have a conditions to be checked, we use the if else statement. Similar to that, even in the pre-processing also we have a conditional compilation. So that is starting with the hash symbol again. Hash if, that is a normal if condition which checks the condition and returns true or false. Then hash if defined, if def. That means if the particular variable is defined or a particular variable is used, and if it is defined in the other file, we want to check if it is already defined to avoid the multiple declarations or a definition of a particular functions or a particular variables, then we use a if def. And similarly we have if and def also, if not defined. So basically these two are used if we want to include header files, then we to avoid multiple inclusions of the header files, there also we use if def and if and def. If not defined, then we'll be in writing the equation where writing the instruction to include a particular header file. Otherwise, it will not execute that part of the code if it is already included somewhere else. Especially when we are using a lot of different header files, there can be a nested header file one inside the other. So to avoid any clashes during compilation, we use this preprocessor. Then we have hash else. It is a else statement for the if condition. And else if, it's a nesting of a if condition one inside the other. We can have else if conditions and end if. So entire block of the if condition ends with the end if. All the instructions will be between these two if and end if instructions. Then we have another directives called undef, which is used to undefine a particular definitions. If we have already defined something and we want to remove that definition, then we can, instead of deleting that, we use a undef keyword. So these are used to maintain the document, and we will know what is defined previously, what we are not using right now, so what we are undefining, all that can be maintained in the file itself. Then other preprocessor, one important thing is hash pragma. This is one important preprocessor. So it is basically used to turn on and off certain features. So we have pragma starter, pragma exit, pragma warning. Like that, we have pragma conditions. So first one's pragma startup. When we use this pragma startup keyword, there will be certain functions which we need to execute before main function. Then we use this preprocessor. We know that always the compilation or the execution starts from the main function. Now, suppose we want some functions to be executed before that, then we will be using pragma startup. Similarly, just before the termination of the program, if you want to execute certain functions, say deallocating memory or cleaning up the memories, something like that, then we can use a pragma exit. So that will be executed only just before the termination of the program. At the end, it will be executed during the exit time. Then we have a hash pragma warning. So this again has three switches, plus, minus, and dot. So one will plus will enable the warning to be displayed, minus will disable the warnings, and dot will toggle the status of the flag. So for the with that we have definitions, that is RLV, that is return value. So if a particular function is not returning a value, then whatever the warning we used to be displayed, that can be hidden using minus RLV. Minus is for the hiding the warnings. Similarly, we have a minus PAR, that is parameters. So if you are passing a particular parameter to the function and we are not using it, then there will be a warning given. So to suppress that warning, we can use a hyphen par. Then we have a hyphen RCH, that is a part of the code is unreachable, then also it will show the warning. So to suppress that warning, we can use a hyphen RCH. Like that, all these are used with a hash pragma keyword to suppress the warnings. Then we have normal function definitions. Usually the prototyping is not required for the C++ compiler, but in the embedded C programming or a strictly C compiler, then we need a function prototyping. Prototyping is just giving a function name, parameter list, and the return value with a semicolon at the end. We are not going to define the function here, it is only a declaration part. Then function, when we are defining, then the same line we will be using without a semicolon. So that will include the body of the function. So return data type, function name, then parameter list, and the body of the program, wherein we will have local variables being declared required for the functions. Then if there are any input statements or invoke statements are there, then that we will be using. Then actually the function definition or the logic implementation, what the function is going to perform. Then finally we'll have a return statements. So this is a standard function model. All the functions will be in the same model what we have discussed here. Thank you. So if you like the video, please click on a like, comment if you have any questions, and subscribe to the channel. Thank you.